Welcome to today's lesson on electromagnets and their applications. We will start today's lesson by exploring what electromagnets are and how they are constructed. Next, we will look into how the strength of an electromagnet can be adjusted by changing the current or the number of turns in the coil. Finally, we will look at the applications of electromagnets, such as in car motor relays and electric bells. So far, we have studied the fundamental characteristics of magnets and magnetic field lines. You are already familiar with the magnetic fields produced by current-carrying wires and solenoids. Building on this foundation, we are now ready to delve into electromagnets. This concept will broaden our understanding of how electric currents can be used to generate and control magnetic fields, leading to various practical applications in everyday technology. Let's get started. Let's first understand what electromagnets are. An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Unlike a permanent magnet, an electromagnet's magnetic field can be turned on and off by controlling the flow of electricity. The basic construction of an electromagnet involves a solenoid and a magnetic core. As we saw in a previous lesson, a solenoid is simply a coil of wire, and when an electric current passes through it, a magnetic field is generated around the coil. To strengthen this magnetic field, an iron core is placed inside the solenoid. Iron, being a magnetic material, enhances the magnetic field significantly. This combination of the solenoid and the iron core makes a powerful and controllable magnet. The strength of an electromagnet can be controlled in a couple of ways. Firstly, by increasing the electric current flowing through the solenoid, the strength of the magnetic field increases. Secondly, by increasing the number of turns in the coil, the magnetic field also becomes stronger. This means we can make an electromagnet more powerful either by using a higher current or by winding more turns of wire around the core. One of the key advantages of electromagnets is that they can be turned on and off. This is done by simply controlling the electric current. If the current is stopped, the magnetic field disappears, making electromagnets highly versatile in various applications. Let's now turn to two of these. Let's begin by looking at how a car's starter motor works. The starter motor requires a large current to operate. If we were to control this large current directly with a switch, the switch would need to be very heavy-duty, bulky, and cumbersome. Instead, car motor relays use electromagnets to control the flow of this high current efficiently. When you turn the car key, a small current flows through the relay coil, creating a magnetic field. This magnetic field attracts a movable iron armature, which then closes a high current circuit connecting the battery to the starter motor. Another interesting application of electromagnets is electric bells. Electric bells use electromagnets to produce a ringing sound. When you press the bell button, an electric current flows through the electromagnet coil, generating a magnetic field. This magnetic field attracts a metal striker towards the bell. As the striker moves, it hits the bell and produces a sound. The circuit is designed to momentarily break as the striker moves, causing the electromagnet to demagnetize. The striker then returns to its original position, ready to strike again when the circuit closes. This repetitive motion of striking and returning produces the continuous ringing sound of the bell. In today's lesson, we delved into the concept of electromagnets, learning that they are magnets generated by an electric current. We discussed their basic construction, which includes a solenoid and an iron core, noting how the magnetic field is strong and controllable. We understood that the strength of an electromagnet can be adjusted by varying the electric current or the number of turns in the coil, and that electromagnets can be turned on and off by controlling the electric current. We also explored practical applications, such as their use in car motor relays and electric bells. Overall, we've gained an understanding of the workings of electromagnets and their significant applications in everyday technology. Watch the rest of the GCSE physics course at Sophos Education.